In this video, we'll talk about the concept of the average rate of change. As the saying goes, the only thing constant in life is change, right? We are often thinking about change, like change in our salary, or change in our weight, change in the number of coronavirus cases, right? I mean, we're looking for how things change constantly in our lives. We've talked about the rate of change of a linear equation in two variables already in this section, and we just define that to be the slope, right? The change in y divided by the change in x is the slope of a line. That formula, if you recall, is y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1, where x1, y1, and x2, y2 are 2 points on the line. Well, we can also write this using function notation. If we say y equals f of x is a linear function, then the rate of change or slope can be written as, well, what? F of x sub 2, right? F of x sub 2, remember y equals f of x, so if our input is x sub 2, the y value is f of x sub 2 minus f of x sub 1 is the y value at x sub 1. And then divided by the change in x, which doesn't change there. So the really important thing to note is that for a line, it doesn't matter which 2 points on the line you put into the slope formula, the slope is constant, right? We'll get the same slope regardless of the 2 points that we use. And so the thing is that we can apply this to any function. The problem is that on some other function, the rate of change will vary depending on which 2 points you choose, because the rate of change or slope is not constant on that particular graph. So we define something called the average rate of change. This will tell us how the function is changing on average between 2 points or in an interval of 2 points. But it's basically this. We find the slope of what we call the secant line. So if we identify 2 points on the function and we draw a line through them, we can find the slope of that line, and that will give us the average rate of change of the function on that interval. And in calculus, you talk about that, and you try to move the point closer and closer and closer to the initial point so that you can talk about an instantaneous rate of change. But we'll look at this with two examples. We can be given a graph or a table or an actual equation of the function to find the average rate of change. And we want to find the average rate of change of this function shown over the interval -1 to 2. So in this case, the -1 to 2 represents our x values, our x sub 1 and our x sub 2. So to find the average rate of change, we have to find f of x sub 2 minus f of x sub 1, and then divide it by x sub 2 minus x sub 1. Well, the 2 points give us what the y values are. We know the point 2, 1.2, and -1, -4.8. And so to find f of x sub 2, it is the y value when x is 2, which is 1.2, minus f of x sub 1 is a y value when x is -1, so that is a -4.8. And then we're dividing this by the change in x, so 2 minus -1. So this becomes 1.2 plus 4.8, or 6, divided by 2 plus 1, or 3, which is 2. So on average, this function changes 2 units for every 1 unit change in x on that interval. Now we want to find the average rate of change of the function f of x equals 2x squared plus 3x minus 4 over the interval -4 to 3. Again, -4 to 3 represents our values of x. So this is our x sub 1 and our x sub 2. To find the average rate of change, we need to know the y values for each of these x values. So we need to find f of x sub 2, which would be f of 3. Plugging in 3 in place of x, we get 2 times 3 squared plus 3 times 3 minus 4. The order of operations applies, so we would square first to have 2 times 9, then plus 3 times 3 is 9 minus 4. So this is 18 plus 9 minus 4, which is 27 minus 4, or 23. Then the f of x sub 1 is f of negative 4. This becomes 2 times the expression negative 4 squared plus 3 times negative 4 minus 4. Squaring first, we get 2 times 16, and then 3 times negative 4 is minus 12, and then minus 4. So that's 32 minus 12 minus 4, which is 20 minus 4, or 16. So now that we know the y values for the given x values, we can find the slope of the secant line, and that is the average rate of change would be f of x sub 2 minus f of x sub 1 divided by x sub 2 minus x sub 1. So we get 23 minus 16 divided by 3 minus negative 4. And this simplifies to be 7 divided by 3 plus 4 is 7, or 1. So this means that on this function, the y values are increasing by 1 for every 1 unit change of x on average. So that is, if you added up all the changes in the y values, you would see that on average it changes by 1 unit between the negative 4 and 3.